Hello guys, today I'll present the solution of the exam that came in 2019-2020 in this course MATS 2108. It was divided into two sections. Section A, fill in the blank spaces with the correct answer. Number 1, question 1 says if y equal to x, if y equal to x varies as a constant power of x, then y is dash of x. Now, to analyze this question, it is pretty easy. If y varies as a constant power of x, it simply means that y is a power function of x. So what we have here is that y is a power function of x. Number 2, a statistical technique used to describe relationships among variables is called regression analysis. That's the answer. The statistical technique that is used to describe relationships among variables is regression analysis. And then number 3, the model given by yi equal to beta 1 plus beta 2 xi plus epsilon I is known as the regression line of y on x. That's the answer, the regression line of y on x. And then number 4, question 4 says a patient is given a drip feed containing a particular chemical and its concentration in his blood is measured in suitable units at 1 hour intervals. The doctors believe that a linear relationship exists between the variables. This is a table containing the linear relationship between the variables. As you can see, they say A, find Roman 1, the sum of x is equal to dash. Of course, the sum of x simply means we should add all of this. So it is 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6, which gives us 21. And Roman 2, they say x bar. Roman 2, x bar. X bar is the mean of x. So it is sum of x divided by n, which is equal to sum of x here is 21 divided by the number of elements in 1, 2, 3, 4, 5, 6, 7. And it gives us 3. Roman 3 says the sum of y. So again, we add all of this. We have 2.4 plus 4.3 plus 5.0 plus 6.9 plus 9.1 plus 11.4 plus 13.5. Adding all of this gives us 52.6. Then Roman 4 says we should calculate y bar, which is the mean of y. So it gives us, we have the sum of y on n, which will give us, the sum of y is 52.6 divided by 7, and it gives us 7.51. And then Roman 5 says we should calculate the sum of x squared. The sum of x squared, we have 0 squared plus 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. We square all of that and add, it gives us 91. And then the next one says that we should find the sum of xy. Of course, the sum of xy means we multiply x and y and then add everything. So we have 0 times 2.4 plus we have 1 times 1.4.3 plus, I'll continue here, 2 times 5.0 plus 3 times 6.9 plus 4 times 6.1 plus 5 times 11.4 plus 6 times 13.5. We add all of these, it gives us 209.4. And then the next, that's Romans 7. Romans 7 says we should calculate the covariance of x and y. The covariance of x and y, we know it is defined as what? The sum of xy divided by n minus xy bar. And we already have this and this, so we only substitute. The sum of xy, we just saw that it is 209.4 divided by, our n is 7, and then minus x bar. X bar is 3 times y bar, which is 7.5. We simplify this, it gives us 7.38. And then Roman 8. Roman 8 gives us, says we should find the variance of x. We know that the variance of x is the sum of x squared divided by n minus x bar squared. So we already have the sum of x squared. This is the sum of x squared here. The result was 91. So we have 91 on 7 minus x bar is 3 squared. We calculate that, it gives us 4. And then the next part, Roman 9 says that we should calculate B1. B1 is coming from the equation of the regression line. That is y equal to b naught plus b1 x. How should I calculate this? And we know that what it is, the covariance of x and y divided by the variance of x. So it gives us that covariance that we just calculated, this, which was 7.38 divided by the variance of x, which is also just calculated as 4. Simplifying this gives us 1.845. And then number 10. Roman 10 says we should calculate B0. This is B0 here. And we know that B0 is obtained as y bar minus B1 x bar. That's it. So this gives us our y bar. Where's our y bar? We already calculated y bar somewhere. This is it, which is 7.51. Then minus b1, which we just calculated as 1.845 times x bar. Our x bar was 3. Simplifying this gives us 1.975. And finally, the last question, Roman 11, sorry, the equation of the regression line. The equation of the regression line is y cap equal to, as we see it, b naught, which is 1.975 plus b1 1.845x is our equation of the regression line, and that completes number 4. Question number 5. This question says that in the expansion of 1 plus ax to the power n, the coefficients of x is 12 and the coefficient of x squared is 54. Find the value of a and n. To do so, we are going to use the binomial theorem to expand this man and then compare the coefficient we get to these coefficients in order to find the values of a and b. Now we know that by the binomial theorem, 1 plus x to the power n is expanded as 1 plus nx plus n into n minus 1 on 2 factorial x squared. So I'm going to end here, and it continues. Therefore, in this our own expansion, 1 plus ax to the power n, we are saying that our x is ax. So we simply replace x in this by ax. It gives us 1 plus n into ax plus n into n minus 1 on 2 factorial. 2 factorial is 2 factorial, and then our x is ax squared plus, and so on. If we simplify this, it gives us 1 plus nax plus n into n minus 1 on 2, because 2 factorial is 2 times 1. Then this is a squared x squared, and so on. This gives us the expansion up to as far as the term x squared is concerned. But the equation said we should find the value of n and a. And they gave us that the coefficient of x is 12. So by comparing coefficients, we realize that NA is equal to 12, saying this is the coefficient of x here, and it was given as 12. And we can call this equation 1. And the coefficient of x squared here is n into n minus 1 on 2 x squared, which is equal to 54. We can call this equation 2. Now solving these two equations simultaneously gives us a as 3 and n as 4, which completes the solution for question number 5. Question number 6 and the last question under section A says that in evaluating the integral of 2x dx is equal to x squared plus c. C is called, well, everybody knows that C is called a constant of integration. constant of integration. And the symbol this is the notation for integral. So it's just integral, which completes the solution for this section.